Today I'm just going to give an update on where I am with the engine now that it was starting and running. I've got the setup pretty close now, and at this particular moment I'm quite pleased with it all. A couple of things that I've done. I talked to Richard Owen about this a couple of times, and I followed up again just recently, and his suggestion is to take those out. These are the butterfly valves that sit inside the throttle body, which is actually across here, and they're connected to the butterfly valves actually in the carburetors. So there's two of them. Anyway, I had the carburetors off, and I decided to actually just take them, given that they were off, I decided to take them out. So these have come out, and certainly no negative impact to the engine whatsoever. I'm not even quite sure why they are there. If anybody knows, I'd be interested to find out. Just seems like an unnecessary restriction, given that the airflow is controlled by the carburetor. The carburetors have been set up with a vacuum gauge. This is the vacuum gauge that I actually use, and I'll show an example of that with the engine running when it's warmed up. That really balances the performance of the two carburetors. I find that quite important for a really nice steady tick over in the engine. I have these carburetors on my TR6, so it's worth making sure that that works well. I had a small issue with the return on the throttle, and it wouldn't go back to the actual throttle stop seat. It was sticking a little bit. I've had the carburetors apart a couple of times for different reasons, nothing serious, but I trying to make sure that my butterfly valves were seated correctly, and there's no resistance there. So when it's actually in the vehicle, this just doesn't quite close correct. So the tick over is at a higher speed and can vary. So what I've done, given especially that I've taken these out, I've used the return spring for that lever mechanism on that throttle body. I've taken that from its linkage associated with that throttle body butterfly mechanism, and I put that actually on this particular lever arm. So there's a lot more force to actually close it, and that seems like that's worked. So that turned out to be very interesting. Not a major tweak, but an important tweak, I think. Not quite sure if you're going to be able to see, but I have a brand new belt tensioner for the water pump belt, and there it is there. You might be able to see that spring. That has really settled down the engine, I think. So this on the old one was bouncing like crazy, and if you remember, I was questioning the belt length of the actual one that I previously fitted. I'll show you that on the bench right now. So this is the old belt tensioner, and I think the combination of this very old bracket, it's really well worn out. The reaction in just generally the whole system was in dire need of a replacement. The pulley was fine. This spring, I think, was just old, and the difference between the tension out of this and the new one was quite significant. I would argue maybe the new one was like 2 times. So that was a contributing factor for the engine settling down a little bit. But also, this is the old water pulley belt that came off, and this one felt just like it was too long. Either there wasn't enough tension coming from the tensioner, or the belt was too long. So the new belt that I got from the same source, actually, has a different part number on it to the one that I was sent previously, and was slightly shorter and was harder to fit. to the engine. So I think this one was just slightly too long. Maybe the wrong one was sent, I don't know. But a combination of the new belt tensioner and this water pulley belt has replacement has really settled the tensioner performance down, and I'm sure that's helping with the water pulley, the water pump efficiency, and everything else that goes with that. So I'm actually quite pleased with that. I'm holding a good temperature on my engine right now, so I'm happy with that. This is the fan relay, and I had significant challenges getting that fan relay to work correctly. So it runs off a temperature sensor that basically says, okay, the radiator water is too hot, please turn on the fans, sends that signal down to this relay, and then there's a live feed that comes from basically the fuse box that provides power to the relay. That opens up a switch to the fan, and then the fans kick in. So I have tried several times to diagnose where the fault is. I had lots of individual errors, in particular bad earthing in a couple of spots, but I've removed all of that and I still can't get this relay to work. So at the moment I have it live wired. Basically, as soon as I turn the ignition on and the power goes to that particular fuse area, then the fans will kick in. So I'm more comfortable running with the fans permanently on than the system overheating and having no means of turning the fans on whatsoever. So I'm a little nervous at this point about cooking the engine, etc. So I'm just being overly cautious, and I'll get back to this particular relay in the near future. So we'll figure that out. Tied up the wiring for the engine. In terms of the ignition leads, this is not an expensive part. Makes quite a big difference. My ignition leads are a bit long. I'll probably shorten those in the near future. Now my ignition light is staying on. So the conclusion that I've come to is that the alternator is fine because it's cranking out amps, and you see that on the actual alternator gauge. In the book, it says that you need a 7.7 volt input at 1500 RPM into this little control unit here. I have this wired up correctly. I am getting 7.7 volts at 1500 RPM. So this was new old stock. So I have a feeling that that this is just bad. So my next step in terms of trying to fix the ignition light issue is that I'm going to get a replacement of that. I'm running out of ideas there. If anybody has better knowledge of that, then let me know. I don't think there's any way of testing that on its own, so kind of forced to make a replacement. I figured out my issue with the ignition wiring, and so all of this is set up, working correctly. I'm very happy with that, and my tachometer is actually working. But I'll show you that with the engine running. So I'm getting the right live feed down to the coil through the tachometer, and I'm very pleased with that right now. I'm still waiting on an alternator shield, heat shield. I got the bigger one. I didn't like it. I just didn't like it. Looked, maybe I could show it on the bench. I'll dig that out. I just didn't like the look of it. So there's a smaller heat shield that basically just sticks out over here, and I'll fit that when that comes in. My exhausts seem like they're running with even temperature, and the early indication on the plugs looks quite even, and I feel at this point quite comfortable with that. Okay, One area where I had quite a decent oil leak, and it was a little annoying, was the return from the oil filter down to the sump. And the leak was just resulting in quite a serious drip from here. And initially I thought it was just the tightening of the bolt, so I did all of that. But in the end I double clamped this joint here. And that seems to have cured it. Outside of that, I'm not seeing anything that is an issue from a oil leak perspective. So I'm pretty happy with that at this stage. One thing I'd forgotten to mention earlier is that I retightened all of the cylinder head bolts down, and they had lifted, the torque had dropped. So it was a while ago since I built the engine. It's been sat waiting to go into the car and get hooked up. I was a little bit surprised to see how much it had dropped. But yeah, very worth doing. I'll check it again after I've driven the car for a little while, but these have all been retorqued down. But a little surprising about how much torque drop off there was, so I'll keep an eye on that. This is the alternator heat shield that I was talking about. It comes in a hammerite finish, I mean, it's a nice part, don't get me wrong, it's not an inexpensive part either, but I tried to fit that and I really did not like the look of that on the engine. For me, it just spoiled it completely. So if people have comments, you know, more people will know more about the straight six than I do, and how important it is to protect the heat shield. But I saw the heat shield on a couple of other videos, which was much smaller and had a better finish compared to, especially when compared to the stainless exhaust. So I'm going to try this other heat shield first. Engine is warmed up. Running quite smoothly. That pulley down there is where the light is the belt tensioner. It's no longer bouncing anything like what it used to, so that's like super steady in comparison to what it was like before. That new spring and the combination of the pulley arrangement, I think, That's really settled the engine down, and obviously is important for the water pump, etc. So very pleasing about that. You can see that I'm pulling amps on the battery, or volts, I should say, on the battery. My oil gauge pressure is good. My temperature is good. So it runs pretty well. I obviously haven't driven it, but right now I'm quite happy with that. And then you can see that I have my ignition light on, even though I'm charging from the alternator. So I'm pretty sure it's that that little electrical system that's beneath the heater box is really causing that. So I'm going to get a new one and see if that helps solve that problem.